or maybe if you're lucky, they've been scanned with a good quality of scan. But to get access to the information that is in those documents, that's one place where machine learning can really be put to use. And we've developed at Bentley an instrument that have hundreds or even is happening with fluid or with just bringing. We'll show you how you can using our APIs directly. So first, I'll just give it and dive in with a demonstration that I've snatched up. Machine learning model is providing, and integrate it in your. We'll just have a small conclusion where we'll. Let's get started with an overview. So it's actually a combination of multiple different machines extract data out of raster P&ID drawings. And I mean, it can be applied to PDF sheets, to PNGs, scans, JPEGs, BMPs, whatever. If you have an image format, it will work. And why are we doing this? Like I explained it a little bit during the introduction, but it's really because a lot of companies are interested in getting those iTwins, but they just don't have any digital information available. So we have to go where the information is. And if it's in the form of paper drawings, then that's where machine learning can really help us, because it can extract both the text information that's present on the drawings, but also the symbology, the connectivity between the different equipment that are present on the sheet. So yeah, this is really what the solution is about. So it can detect equipments on the drawing. It can also detect unique tags for these equipment and associate the tags with the right equipments. So that this allows you to create a registry of all your tagged elements on your drawing. And finally, if you are willing to put a little bit more effort and really review the results that the machine learning process is giving you, this can also be the start of a recreation process. So if you're thinking of updating a plant, you have some changes to do on a process line, and you'd like to have an up-to-date drawing. If you only have a scan document, then you have to recreate the whole drawing. But with machine learning, you can start from everything that the machine learning algorithm has been able to extract, and then you simply have to add a couple of changes and make sure that you review what the machine learning process has given you, because it's not going to be 100% accurate, of course. So that's it. Let's dive in with a demonstration of the tool. And I've actually I've been surfing the web, and I managed to find this old P&ID drawing. It's actually from the NRC, the Nuclear Regulatory Commission. So they have a bunch of open access drawings from old plants. I think this one, some of the sheets, they date back to the 70s, like you can see here. And this is actually a hand-drawn P&ID. You can see the symbols were hand-drawn, the text was hand-drawn. And actually, our solution works. It works fine on hand drawings. Of course, sometimes the OCR is not as accurate. The OCR, the text recognition part, OCR is optical character recognition. So, of course, it's not as accurate on hand-drawn characters, but it's actually doing a pretty good job. And here, actually, what I got was a multi-page PDF. And some of the pages are more recent than other. Like here, it's a vector drawing. I mean, it was scanned, but you can see it's not hand drawn. But some of the pages are hand drawn. Others, and some can be pretty messy, pretty dense here. So there's a lot of stuff going on here. So what I did is I uploaded this drawing, and I actually already ran I actually already ran the machine learning algorithm on it, because it can take around 20 minutes to do it. But if I hadn't done so, what we can do is just, like, for example, here I have another sheet. This one's just a PNG of a simple P&ID drawing. So you can just add the image. You just drag and drop it. Let's get started, and the file just gets uploaded on the SAS, and then you can just select it to run an analysis, and it will kickstart a node in the cloud so that it launches the machine learning pipeline on this drawing. And maybe at the end of the session, we can see if the results actually completed for this. But what I'm going to do is actually go ahead and review the result for this file. So I can click View Analysis here and look at everything that's been extracted. And actually, the machine learning algorithm was able to extract over 9,000 objects from those sheets. And we can also see a breakdown of the objects that were extracted per sheet. So actually, we have 35 sheets in this drawing. But this is machine learning. And machine learning, it learns from examples. So the model that we are giving you access to today, it's actually been trained on hundreds of P&IDs from different clients who use different symbology. So across time, there were different standards. Sometimes there weren't really any standards at all. A lot of different companies were using different symbols depending on where in the world they're located or whatever. So we have a machine learning model that's learned to recognize what a valve or what a pump looks like, no matter what the symbology is. And this is pretty accurate, but it's not 100% accurate, and especially for rare elements, like some vessels that will look very peculiar. Maybe they are actually unique. So the machine learning model is going to be a lot less accurate when it hasn't seen a lot of example of something. So it's really important, if you want to have accurate representation of your information, to go back and then review the predictions that the model has made. And actually, we use this as feedback. So the model is continuously learning from what the users are giving us as feedback. And if they're correcting something, then we can expect the model to get better and to learn from those mistakes, and to be making less and less mistake over time and be more and more accurate. So I'll just click here and hit review process, and we'll open just the first sheet for review here. So the first thing that you'll see is those yellow bounding boxes for all the elements that have been detected. And we actually get a breakdown of the different classes that were detected. So all of these classes are standard classes that are part of a standard schema. So it's easy to import them later in a digital twin or in an iTwin, and to cross-reference whatever has been extracted here with other sources of information. And what we can do is we can go ahead and pick any category here, and we'll see all of the elements that were part of this gate valve category. And actually, the model is not only detecting the symbols and creating a bounding box around them, it's also trying to recuperate some unique tags for each of those symbols. So we can actually classify the object by tag, and then I can click on one of them and start reviewing it. So we can see here that it was able to grab this tag here, recognize the text that was written there, and associate that this tag number was actually belonging to this valve. So every time I review an object, I can either approve it if I think that the machine learning model has done a good job with it. I can ignore it if I'm simply not interested in that class of object, for example, or I can delete it if the model was actually wrong and shouldn't have detected anything there. So here, everything looks fine. I just want to go ahead and approve it. Here, you see we have another gate valve, but this time, if we look at the text, it looks like the model was actually confused. Instead of an 8, it actually seems more like a B to me. So we can go ahead and correct this and make sure that when we aggregate this data, the user label, the tag will align very well with other sources of information. And I mean, this is something that you'll see happen more often on hand-drawn drawings, or on drawings where the scan quality is a little bit less accurate. But it's something that can happen. And what we usually do with this is that we can also provide a config file where for each class of object you can define a regular expression about what the tag should look like. So for example here, if we had known that the tag for a valve should be a letter, 3 numbers, and then maybe an additional letter, then we would have been able to correctly get this character and say, okay, this looked like an 8 to the OCR, but really it was a letter because it's supposed to be a letter here. And what's most likely is that the 8 was actually confused for a B, and we can put the B automatically. So that's something that we can do. But here I didn't I didn't create any config file. Maybe there isn't one available, so we can still review this manually. Then I can approve it. And here we have a bunch of other valves. They don't have any user label. They're just generic valves, so we can directly approve them, and we can see if there are maybe other valves that we might want to tweak the results for. So yeah, here, okay, this one is fine. It's got the right tag. Another generic valve here. Yeah, oh, here's an interesting mistake. So actually here, further, there's a couple of mistakes here. So first, the model actually detected two of those valves together as just a single object. So I might want to adjust the bounding box here, for example, to just center on this valve, and then it actually put together both of the tags together. So I just want to clear that and make sure that I have the right tag. And actually, this one is not a gate valve, right? It's a ball valve. So I can just go ahead, select the right class for this, and approve it. And what I will want to do is go back here, and I can directly go and add a new object for the other valve that wasn't detected. So I can go here, drag a bounding box, select ball valve again, and I can enter the right tag number, and that's it. So we see I'm making progress here on my review, and I have reviewed 24 elements out of the 316 that were detected on this sheet. And yeah, that's the way you can go and review all of the results. And sometimes what's also helpful is if you have some categories. For example, if you're looking at the reducers, usually they won't have any specific IDs or any tags. So you can go ahead and just look at the sheet, and oh, I see here that there's actually one that's wrong here. So this is not a pipe reducer, it's a plug valve actually. So I can just go ahead, enter this, and then click approve. And this one here, yeah, this is not a reducer, it's just it seems like the ref triangle here, it's got just a line that confused the model. And we can also see here, I have a confidence level for the model. So most of these mistakes, they will happen for elements that have low confidence. So for example here, I can go ahead and I will just delete this because this is actually not an equipment. And everything else, yeah, it looks like these are really reducers. So I can have a quick look around, and I can select everything else and just bulk approve them, and boom, I have approved 17 more elements. And yeah, that's just the way we would go ahead and review all of the equipments here. So, and if I want, I can do it for the second sheet. So as we saw earlier, this one was not hand drawn, so it's actually there's probably a lot less mistake there to correct. And that's the way you go ahead. And when you're done, you just click done. It will save any review changes that you've done. And yeah, I can see a breakdown. So I have 41 objects here that are approved and that are ready to be imported in other workflows. And the way I can do it is I can simply select download all here, and it will download all of the information for my files, which I will then be able to access. So it's going to take a little while because there's 35 files. So what I'm going to do is just open here Visual Studio Code, where I actually already downloaded the data for the first sheet. So here, first you get a JSON output. So this is the output that you're going to get, and there's just an asset section on the top where you will get some information about the file itself. So you'll get, so every time we run a P&ID sheet, we also produce an output PNG, which will have some specific dimension. And this is important because actually what we are doing is we are giving bounding boxes in terms of pixels. So it's important that you get the size of the raster image that we output. So if you want to overlay the bounding boxes on top of it, of course it will fit. And why do we provide also a PNG? This is because when you have scan drawings, sometimes they can have a little bit of a rotation in them. So as we correct that, the output can be a little bit different from the initial image. So if you provide a PDF that had a little bit of rotation in it, we really want you to use the output PNG to display the bounding boxes. Otherwise, they won't fit. And that's something, the machine learning model performs better when the image are aligned. So that's something that we do automatically as a matter of just pre-processing the file. So After that, you'll get the region section of the JSON, where for each object, you'll get a bounding box with coordinates for the top left corner and height and width of the bounding box. And then you will get a number of interesting fields. So the user label is the tag for the object. You will get a confidence level for the model. So for example, here the model is reconfidence in what this object is. And then you'll get a class for the object as well. So here, this is a ball valve here. So I could import this. It's a ball valve that doesn't have any user label, but I can say that there's a ball valve here. And finally, you also have a status. So this one, it's not been reviewed yet. But if we had reviewed the object, then here you would see either approved, deleted, or ignored as the status for the object. So there's a couple of different workflows that you can do with this. Of course, you can just have your registry. You can count the number of ball valves that you have in your drawing, or something that you can do is link this with other sources of information. So for example, if you have a field engineer that's looking at a process line and there's a leaky valve, for example, and can note directly what the tag number is on the valve, and he wants to bring up the right drawing to know, okay, what's the fluid that's running through that pipe, what is it gonna affect if I have to do changes on that line to replace that valve. Then you can directly query for that valve tag, and if you have extracted the information, then you can easily query for the tag number because you will have it in this output JSON automatically. So that's pretty much it. So we have a section for our regions. We also have sections for the links, the pipes that link the regions themselves. So we can establish relationship also between objects and say, okay, this valve is feeding this pump on this process line, for example. Yeah. So that's about it. Now I will hand the microphone to my colleague Justin so that he can show you how you can access this machine learning model from our APIs.
Hey guys, my name is Justin Darty. I'm a software engineer here at Bentley with the iTwin platform. And one of my main responsibilities is working very closely with Carl and the Applied AI team in general, and helping them to take the ML models that they've created and trained, and sometimes even the prototypes, and helping them take those and put them into web applications and making them available through something we call the ML REST service. So in this diagram I have up on the screen, this is just a short refresher of the overall schematic. You can see that we have our Gen 2 Azure storage as well as ML REST service, which we've developed. Basically, ML REST service is a collection of very powerful endpoints that allow you to do a lot of things related to machine learning. Anything from reading and writing your data to creating snapshots of your data, even kicking off entire ML pipelines. You can all do that through this collection of endpoints. So it's a very powerful service that can really spice up a lot of the web apps that are being developed out there. Now, in order to keep this compatible with all the different types of web apps and different data types that you're dealing with, because machine learning can entail a lot of different data types, we have a level of indirection here known as ML Core. And ML Core is basically this TypeScript interface that interfaces with a lot of these web apps, such as the one that Carl just showed you, the P&ID workflow that he went through manually just now. Also, if you're dealing with 3D eye models, the ML labeling tool is an example of a custom in-house annotation tool that we've built. And just like the P&ID workflow that Carl just showed, it interfaces through ML Core, and it is able to access the underlying ML REST service endpoints. Now, for the purposes of the P&ID workflow, I won't be going through all of the endpoints, but I do want to point out that we do have pretty good documentation written up on how to set up that entire workflow and how to go about using all of the endpoints. But I do want to single out 5 endpoints in particular that I feel are pretty essential to this overall process of bootstrapping you and getting you off the ground running here with batch processing your data. So if you think back to the P&ID drawings that Carl just showed you, it was a very large PDF with hundreds of pages, each with hundreds, if not thousands of symbols. And the P&ID workflow involved him manually uploading that one PDF file. Now, the power of the ML pipeline is that you could basically batch process these in a scripted way by interfacing directly with the API. So I'm going to be going through these 5 endpoints that I feel like are pretty essential to the overall process here. And some things I am taking for granted, just the authentication step in general, also the P&ID drawings themselves, I'm just reusing exactly what Carl just showed you. So that's kind of goes without being saying, you're going to have data to be annotated. And of course, just creating and configuring a completely blank slate project. So nothing else in there with the project other than you've just created an ID. Also, probably with the proper scopes. That is also important. But all of that is included in the documentation on that link that Carl shared. And I will be, for purposes of this demo, jumping directly into the create inference endpoint. So let me switch on over to the create inference endpoint. So I'm going to be starting over from scratch as much as possible here. And really all you need to get started is that project ID. So if you go to that screen that Carl was on earlier and you pull out this specific GUID here, that is your project ID. This will allow you to retrieve a inference ID, which at that point you are using pretty much for the rest of these endpoints. So this is really the only time you even need the project ID, just to instantiate kind of your workspace here, which we are calling the inference workflow inference ID. So for the body, the only thing that needs to be changed here is the model version. And the model version you can think of as the current best model there is. Right now, I think 1.2 is actually the only option. I don't think 1.1 is even available anymore, but 1.2 is the current champion model. So it, in theory, is the best at identifying symbols in the P&ID document that I will be uploading. For project ID, oh, sorry, I put this in the wrong spot. So first I need to authorize myself. At that point, I need to put the project ID in the body, not the headers. There we go. Now this makes a lot more sense. So that should be good now. And again, authorization, that's just tied to my Bentley account. So all I had to do was select authorization code and we're good to go there. It sets up the HTTP request for me and I should just be able to hit execute. Hopefully it works. Yep, it looks like it worked. So we have successfully created our inference ID, which we will then use for our other endpoints. So once we've established our workspace here, the blank workspace for the inference job that we're going to be doing, we at this point need to actually upload the data. So Carl did that by dragging and dropping it into the interface, but you can do it programmatically as well, which is what I'll be doing here. So let me start over as much as I can. So I'm simply going to this upload inference input content endpoint. So this one is a little bit more complex. You have to provide the authorization, of course, in the beginning, but then use the inference ID that we just created in the last step. So I need to copy this and put that there. Now for the content disposition, I have a specific formatting. And again, this is written in the guide, but to save time, I have it here on my clipboard buffer. I'm just going to call it this. This can be any file name, essentially. Really, this is just the name. It's to upload the actual binary, you have to select it. So I'm going to select it here. I have it saved locally. You could also just enter in the URI right here, and it will pull it down from the internet for you, download it, and then attach it as a binary. So I think that should be good now. Let me just change the file name to something more meaningful, which is the actual PDF document. Let me just proofread it. Everything looks okay. That should be the right inference ID. And binary is attached. Yeah, so let me try executing this. Hopefully it will work. Oh, yep, there we go. So we got a 200 OK. And if you glance down here, it shows you that it has now created a file name of the one that I gave it with the correct size. So we have our data up there. We have our inference workspace. We're pretty much ready just to let it go at it. So all we need to do now is to create the actual inference run. So let me again start over. So just go to this endpoint and click try it out again. Make sure to authorize yourself and then provide the inference ID. So I think it was that GUID. A lot of GUIDs in my clipboard buffer now, so it's kind of getting confusing. But yeah, I think it's the 7.8 GUID should be the most recent one. And actually that's it. Everything it needs is just the inference ID. So I think I should be able to hit execute here. And it looks like it successfully created this job. So if you look down in this response, you can see the preliminary status, of course, is in progress. Now, this is a very big PDF with a lot of pages and a lot of symbols per page. So it will take it a little while to get through that. So to save time here, I have done my own run ahead of time just to show you what the response would look like a real life response. So this is how, I guess before that, if you do want to check up on it, you just simply ping this endpoint. So pop in your inference ID and it will just tell you basically if it's still in progress or if it's finished or any of the other states that are possible while you're waiting. So this is the past run that I did earlier this morning. If you scroll down, you can see that it created the JSON, or actually a lot of JSONs for the different pages of the PDF file. And those will be of a identical format to the format that Carl was stepping you through earlier in his segment. And really, that's it. It was that easy. You pretty much just went through and let your ML model identify all of the symbols in that entire PDF. Now all it needs is a human eye to audit it. So I think that is just about it. If you have any questions, again, please feel free to reach out. The documentation that Carl shared in this link